Alright, if you're watching this video, it means that you're here for Math 1. You're in Unit 2, Lesson 3, the name game. So we're going to jump right in with the homework helper for today. First couple problems, they are just exponent practice. The biggest hint that I can give you here is please follow the instructions. Sometimes they are asking you not to fully solve something and just to go through and simplify to a certain point. These problems are exactly that. They go through and it says use rules of exponents to rewrite each of the expressions with only one exponent. That being said, when we look at this one here, this first one, problem number 2, it's saying 6 to the 4th all raised to the second power. So we've got a power to a power. This is the only time where you're going to multiply those powers. So when we're looking at this, we're going through, we're going to say that this is really 6 to the 8th power, because 4 going up to the second power, we're multiplying to get to here. It is asking us to leave it with one exponent, so we're going to stop right there. So please, as you're working through these, don't go too far. Please stop. We're trying to make sure that you're not doing too much crazy here. For problem number 7, we are going to go through, we're going to look and say, all right, we've got n to the c power over n to the d power. This here, it means we've got the same base. It's a division sign, which means we're going to do subtraction. Because we don't know what's larger, we're just going to say the numerator minus the denominator. So we're going to look and we're going to say, all right, our base stays the same, and then it just becomes to the c minus d power. We don't know what that's going to come out to be, but we're all done from there. And so that's all right. So we're picking up here on page 2. Where it goes through problem number 9. It says find the missing values in each of the geometric sequences, then write the explicit equation and that describes each function. If you've watched any of my videos before, you know the clues are always written in pink. It's the things I want to make sure that we know. That up there is the geometric explicit equation, where a of 1 is the first term, r is the rate, and then a of n is the term that we're looking for, with n being the number term that's there. So when we look at this, I'm going to show this one out. Some people might be able to look at it and say, oh, we know exactly what the R value is right off the bat. I'm going to show us just out here so that we can kind of see it. If I'm missing a term, but I know my first term, that's a beautiful situation for us to be in. It means that I know a of 1, and we know what it's going to be. It's going to be the first y value that we have. But when we're given another term where we know both the x and y, what we're going to do is we're going to take the y value. So let me change our color here real quick. We're going to take these pieces here, and we're going to call those our n value, or x in this case, and then our y is 45, which is our a of n. So we're going to go through, we're going to plug into this equation. We're going to say, all right, well, 45 is equal to our first term, which we know is going to end up being 5, times our r, which we don't know, and then 3 minus 1. And just so we know, the 45 came from over here on our board, our 3 came from here, and then our a1 is just our 5, which is located here. Now I'm going to get rid of all that. And then it's just some basic algebra that go through and solve for what is our r value going to be, because we can't have an explicit equation without the a1 and the r. Everything else don't really care about, but we need an a1, we need an r. So when I'm looking here, first thing that I'm going to go through and do, I'm going to divide by 5. What that 5 does, we cancel out here, and we're left with, 9 is equal to r to the second. And we can square root both sides, and we can get that our r is going to be equal to 3. And as always, per my videos, it will go through anything circled is important, but not a final answer. So we get our r is 3. So we're going to go back up here, and we're going to say, all right, well, if we're looking for a of n, our explicit equation, is equal to, we know our a of 1 is 5, that doesn't change, times our r, which is 3, to the n minus 1 power. This here gives us our explicit equation. However, that doesn't show us what it is that we did differently. It doesn't show us what the missing box is. We can go do one of two things. We can take the 2 that's located in our table and plug it into our equation, or we can just look here and say, all right, well, if we have 5 and our rate is 3, we're going and we're just multiplying by 3. So if I did that, 5 times 3 gives us 15. If we really want to check and make sure it works, 15 times 3 gets us to 45. So that all looks like it's going to go through and shape up. So we're going to move on to our next piece here, which should give us, all right, looking at page 3 of our homework here, we have a 4-part question. We got a couple of them that we're going to look at. It goes through and asks us, based on each of the given representations of a function, determine the following. A, is it linear, exponential, or neither? Great. If we get a neither, we get to stop. If the function's linear or exponential, state whether it's discrete or continuous. Cool, we can do that. Identify the rate of change as a slope, the common difference, or the growth factor, the common ratio. Change as the common difference will give us an arithmetic, that'll give us a linear equation, or if we're looking at the common ratio, that's going to be a geometric exponential. And then it wants us to, in part D, to write out the explicit equation, depending on which one that we have. So I'm going to move this up here. I will zoom in and out, kind of bounce around. Our question 13, the population of a town Y is 15,000 people and is growing by 1.5% per year. So when we look at this right off the bat, we will go with purple. We're going to look at A. It says, is this going to be linear, exponential, or neither? Because it's increasing or decreasing by a percentage and not a staple amount, 100 down 100 plus 100, whatever that is, we know that this is going to be exponential. So we get to put that right in there. Now, unfortunately for us, we were kind of shooting for neither so that we go faster, but that's not the case in here. So we look at problem part B. If the function is linear or exponential, state whether it's going to end up being continuous or discrete. So same thing, we've done problems like this before. Yes, people are going to be being born and people are going to be passing away, but we really only track the population of a town once a year. So we're going through, we're saying, okay, January 1st of this year, it was here. January 1st of the next year was here, and here, which means that this is not going to be continuous. It's going to be discrete because it's going to be broken up, only taking the total population once per year. So in this, we're going to list this out as being discrete. Part C is asking us to identify the rate of change or the growth factor. We already talked about that. We're looking for the ratio or the growth factor because this is an exponential. And this is increasing by 1.5% every single year. So this is going to say that our ratio is going to be equal to, and remember when we're doing percentages, we have to move the decimal over 2 spots. So we're going to say our ratio is going to be 0.015 to get to you. Now, our part D in this is write the explicit formula. Our explicit formula in this case is going to end up being y is equal to it, and if you need to look up what this equation is, go back about 3 minutes in this video. We're going to look and we're going to say, all right, we have our original population, and then we're going to multiply it by 1.015 because we're increasing, which means it's always got to be greater than 1 when we're looking at this. And then it's to the x power because every year that's going to keep growing, and that's going to be a wonderful, wonderful way of looking at that. Cool. So 14 is asking us the same 4 questions, so I apologize for taking that off the screen. We'll change it up here to give us something different to look at. We're looking, and Joan earns a starting salary of $30,000 per year and will receive a raise of $2,500 per year for the first 10 years. So we look at this, and it first asks us, is this linear, exponential, or neither? If she's receiving the same raise, the same number, she's adding $2,500 every single year, this is going to be a linear equation because it's going up. We're adding or subtracting the same piece, same number every single time. Part B asks us, hey, is this going to be linear or discrete? So the same thing. She's not casually earning, $100, $200, $300, $400. She's getting that paid at the start of each year. So this is also going to be discrete because she's going to see that jump in her pay at the end of the year, not continuously throughout the entirety of the year. So part C was asking us to go through and figure out, all right, what is going to be the common difference or the common ratio? Since this is linear, we're looking for the common difference, which is going to be a positive 2,500. And I'm sorry, I'm going to write in here that this was a rate or common rate. Part D was asking us for an equation. This one's going to look as close to y equals mx plus b as possible, except it's going to be a little bit reversed. So we're going to look and say y is equal to her starting salary of $30,000 plus $2,500 for X number of years. So we're going to end up here with this equation. Yes, y equals mx plus b. We would flip those two and put the 30,000 at the end. Either way, it's going to be correct. We're just going to go through and write it this way just to kind of keep things up and moving. We're going to go through, we're going to power through to one more of these, which is located on the next page. So I apologize here. We're going to go over to number 18. 18 here is building a table. Like I've said previously, I like tables. If we went through and we just called it X and Y, we could go 1 to 1, 2 to 4, 3 to 9, 4 to 16. We clearly see that there's a relationship between these two. We're going through and all we're doing is we're saying, okay, y is just going to be equal to x squared. That's great. Anytime we plug x in, we know what the y is going to be. But does that give us a linear equation or an exponential? And the answer is no. It looks like an exponential, but in an exponential, the variable has to be up in the power. It's not the other way around. It's not the variable has a power. Yes, that's going to do some cool parabola thing in here. But when we're looking at this, we cannot have this be linear, because linear means that the x is to a power of 1. And it can't be exponential, because the x isn't in the power. So in this case, we get to go through and actually write, that this is a neither. So we can stop what we're doing. We don't have to answer parts B, C, or D, because it tells us if we get a neither in part A, then we're just going to be done with that. So moving on to the next problem, we're going to look here. So picking up where we left off, this is a problem. We're moving on to problems 21 and 22, which unfortunately the instructions were printed at the bottom of the last page, so I'm just going to read them here. For each geometric sequence below, find the missing terms in the sequence, then write an explicit rule for the sequence. I am a big fan of finding the equation first. I think it makes my life easier, especially when we're given the first term. If you're confused by what's written on the board right now, go back to the beginning of this video. I walked through one of these, but I'm just going to pick up here in the blue where we went through and I just plugged into our pink equation, which is our geometric explicit formula, where I said, all right, I have 162 here. That's what I'm going to plug in for my a of n, which is located here. I have my 5. I have my 5, which is what we're plugging in for the n value, or what I'm going to refer to as x occasionally. And then we go through and we have our a value is just going to be the y value. A of 1 is just going to be our y value for our first n value, or x value. So we're going to go through, we plug those into the pink equation and got the blue equation. And now I'm going to solve for r. So I'm just going to go through, I'm going to say, all right, let's divide by 2. What that does is it gives us 81 is equal to r to the 4th power. So we can go through and use our calculators. A lot of us have only really done, taking the square root when it's r to the 2nd power, or a to the 2nd power, b, or whatever it is to the 2nd power. When we do this, we're going to go through and we're going to take the 4th root of both, which your calculator should be smart enough to do. And when we do this, we get that our r is equal to 3. If you really want to double check me, just go do 3 to the 4th power. It should end up giving us 81. So that's great that we were able to figure out that r is equal to 3. And like I said, I like going through and writing down I like circling things that are important, because then we're going to go back to our pink explicit equation here, and we're going to say, all right, well, we're looking for a of n. Let's come up with our equation. Is equal to our first y value, which we know is 2, times our rate, which we now know is 3, to the n minus 1. This here is going to be our equation. And that's great that we're able to find that so easily. But we do need to go through and say, how do we figure this out? So we're going to look, and we're going to say, well, we know what our rate is. Our rate here, we'll change it up. Our rate is just times 3. So if we go through and try this out, we say, all right, if I'm looking here and I have a 2, let's do 2 times 3 to give us 6, 6 times 3 to give us 18, 18 times 3 to give us 54. And just for good measure, does 54 times 3 give us 162? And it does. So we're able to go through mathematically solve through the algebraically solve for our R without playing this giant guessing game that I'm sure some of you were trying to do. Just do the math, work it out every single time, and we'll be fine from there. Now, we're going to go through, we're going to look at problem number 22 as well. Doing the exact same thing. I did not write this one down earlier, so let's do this real quick. We will go with a color choice here. We'll go purple. And we're going to just plug into the same pink equation that we have right here. And bear with me. There we go. But we're going to choose new numbers. We're going to say that our a of n, which we don't know the last term, but that's fine. We're going to use this as our major points. We're going to look and say -3 is equal to 1/9 times r to the 4 minus 1 power. And all we're doing is we have those two highlighted pieces there. We're also using this 1/9 that's located here. So now that we have that, I'm gonna go up so that we can see this. And we're just gonna cycle through and try solving things. If we go here and we say, all right, how do we get rid of a 1/9? We're just gonna go through and multiply both sides by 9, because what that does is it just cancels these out. Sorry about that. So we're looking at -27 is equal to r to the 3rd power. And then we're doing the same thing we did on last one, except we're just taking the cube root of this and saying, all right, what is the cube root of each? And we're getting that our r is equal to -3. And if you're curious about that and you don't believe me again, go put -3 to the 3rd power, make sure that that negative's included, and you're going to go through and get -27. Now, we're going to do the same thing. We're going to go back and we're going to plug in. We're going to look and say, all right, we've got our y. Oh, let's not call it y here for the sake of things. We'll stay consistent. If we have a of n is equal to our 1/9, because that was our original y value, times our r, which we know is -3, all to the n minus 1 power. So what we're saying is we're going through and we are dividing, I guess, by working backwards. We're dividing by -9 every single, but we're multiplying by -3 each time. So if we go through and I start plugging in, I'm going to erase these here just so we get them, but I'm going to circle back. We're going to start with 1/9 and we're just going to multiply by -3. So we get -3/9, which is -1/3. Then we go through and do -1/3 times -3. That gives us +3/3, which is 1. 1 times -3 is -3. Good, that works. And then -3 times -3, which gives us 9. So we end up with these wonderful, wonderful pieces in here, and then we can go from there. We've got one more page left. We're going to go do that here momentarily. So we end with a great two last problems, two things that I think many of you have seen before. Should be a nice way to kind of knock the cobwebs off your brains. When we look at this problem, it is, once again, printed, the instructions printed on the last page. It has asked us to go through and find the slope, or the rate of change here, which is, as we know, and I should have written this before, is that our m, which is slope, is just y2 minus y1 over x2 minus x1. So I apologize, try to have that up and running beforehand. So when we look here at number 27, we're given 4 points. It doesn't matter which two you choose. I'm going to go through and just choose the first two, just so that we can go through and try to solve this. So when we do this, we know that our slope is going to be, it doesn't matter which one's your y2. Doesn't matter. I'm going to choose 24 just because it's a bigger number. So we say 24 minus 20, and then we just have to pair things up down with our x's. We're going to look, and if we chose 24, we better choose -5 because that's what's attached to it. So we get -5 minus a -7, which gives us a +7 to get here. And then we just go through and we solve, and we get 4 over -2, 4 over +2. Sorry about that. Which is going to go through and ultimately simplify into 2. And that's all that we're being asked there, so I'm not going to go through too much with that. Problem 29 is my favorite one on here because there is zero reason to do any math. All we have to go through and do is find 2 points. So I'm going to go through and say, oh, there's one there, there's one there. And then I'm always going to choose the left one and work my way up and then over. So in this case, we're going up 1. So I'm going to say up 1, and then to the right, 4. So we go through and we say 1/4, and that's equal to our M. And that is everything that we need to know for this section. So if you have any questions, please talk to your teachers. Other than that, I hope you all have a wonderful